Hello, everyone. Welcome to today's webinar. Really glad you've all been able to join us. We've had absolutely ton of registrations for this webinar today, so it's clearly a very popular topic, and we're looking forward to getting into it with all of you. For those who don't know me, my name is Dylan Atlas Baker. I'm one of the co-founders here at Spectacles. For those who may have signed up for this webinar not knowing who Spectacles is, we are a continuous integration tool for Looker. So we help you run automated tests against your Looker instance as you're developing in LookML to make sure that your Looker instance is bug-free, that your developer experience is good, and that everyone across your instance has confidence in your Looker instance. That is all I'm going to say about us today. Really excited for today's topic. We've got Philipp from DoiT here, who is done a ton of work around cost and performance optimization using BigQuery and Looker together. And we're really excited to see kind of what he's going to talk about. I've seen the slides already, and it's really, really interesting stuff. Before I hand over to him, I just want to talk about a couple of the webinars we have coming up. We've just announced the next 3. So for those who haven't attended these before, we run these webinars every other Wednesday, every 2 weeks. Really focused on interesting areas of the Looker ecosystem. So it's not about spectacles. It's really about getting people who use Looker together and talking about something interesting. And so next week, in 2 weeks' time, we've got a kind of this sister webinar to this one, which is optimizing Looker performance on Snowflake. So I expect most of you are BigQuery users, given that you're here today. But if you, for whatever reason, use both, we've got that one in 2 weeks. We've then got a session with myself and my co-founder about building custom map visualizations in Looker. And then we've got one from the team at Scopely 2 weeks after that, talking about how they've scaled, Looker to a multi-instance deployment for multiple different use cases. And so if those are of interest, you can always head to spectacles.dev/webinars. You can sign up for all of them. Even if you don't think you're able to make it, if you sign up, we will send you the video after the fact. We record all of our webinars. And so make sure to do that if any of those are of interest. Equally, if you have anything that you'd love to see covered or would like to talk about yourself, get in touch and let us know. We're always planning more of these. They come around every 2 weeks pretty fast, so happy to speak to anyone about that as well. The last thing I'm going to say, which some of you will have heard me say at the top, before I hand over to Philipp, is that we're going to have a Q&A at the end of this, and we manage all of the questions for the Q&A in our community Slack. And so Josh has just dropped a link in the chat. If you click on that and join, you'll find a channel for this webinar, BigQuery cost optimization. Head over there to let us know where you're calling from. But also, if you have questions as we go, write them in there. Other people can kind of upvote them and provide some context along the way. But also, Philipp and I'll make every effort to answer all of them at the end of this. That's it from me for the moment until the Q&A later. So on that note, I'm going to hand over to Philipp.
Perfect. Thank you for the introduction. Just share my screen. Perfect. Cool. Yeah. Thanks for the introduction. My name is Philipp. I'm a data architect at DoiT. Specifically, I'm working on the Looker and BigQuery stack, trying to make customers happy. Happy in the space of the cloud. For those who don't know DoiT, DoiT is a reseller, a technology partner for all things cloud related. We support across all the clouds, AWS, Azure, and Google, of course. And we try to be a technology partner helping with our customer engineers to actually make the most out of the cloud. And today's talk is actually just a small recap of my day-to-day work. So because some of our tickets, some of our customers actually talking a lot about cost optimizations these days, while others aiming for performance. And usually when we talk about cost and performance optimizations, they don't go hand in hand. Usually you can have either the one or the other, but it's usually a little difficult to bring both worlds together. And I will try to find the overlap in today's webinar. So I hope everyone sees the overlap. If not, reach out to me and then we can see if we can find the overlap afterwards. Today's agenda is about basically 3 items. First, we are going into the dashboard costs of Looker. I will show one method, how you can bring the billing data together with the usage data in Looker. We actually will have a small dashboard to see how expensive the dashboard is and how expensive an Explorer is. Then I will cover a little bit of a method how to speed up dashboard queries. There is one specific element in the BigQuery area that I want to talk about to make queries faster. And lastly, it's about slots. Everyone who is working with BigQuery at a large scale should know what slots is or what slots are. But I will shortly recap what slots are and why they are maybe beneficial for you when it comes to bringing down the costs. It's not about, or the session in general will be not about don't write select star queries in BigQuery. It's not about how to set up monitoring or logging for specific queries in BigQuery. I just picked 3 items that are day-to-day work for me to optimize for cost, optimize for BigQuery performance, and also trying to bring them together. So let me start with the first one. The first one is actually the most technical one that we are talking about today. So when we talk about in this example, in this screenshot here, when we talk about Looker, I mean the real Looker, right? I'm not talking about Looker Studio. I'm talking about the real Looker. So what we are trying to achieve is to bring together the system activity data, the usage data that Looker already offers everyone to analyze. And we want to bring this together with billing information or access information. Basically, the billing data, as soon as you have a billing account in the GCP world, you can export the billing data to BigQuery right away. There's very easy instruction how to do that. This is one step, and the other option would be to use access data. I will talk a little bit about both data sources later on in more depth, but definitely you can bring together billing data, or you can bring in billing data into BigQuery. On the system activity side, this is basically the information that we have about Looker usage, and we want to bring them together, join them in one table, and later on we will build a dashboard on that one. This is what we are going to try out in the next couple of minutes. But before we go into the examples, I would like to cover the data sources a little bit deeper. So first of all, on the left-hand side, we can see the system activity data. This is the meta database that Looker uses under the hood. It's built into Looker, and it's logging all the queries that are generated via an Explorer, via SQL runners, but also for all the dashboards. Everything that is actually being sent to the database that has some magic of Looker in place is being logged as at least a history entry in the history table. There's also much more tables available for users, for dashboards to figure out if the dashboard runs on a schedule and so on. So if you haven't looked into the system activity data yet, I definitely encourage to do that. There's lots of data available about caching, which is the most used branch in your Looker instance and so on. So there's definitely a lot to unpack, but unfortunately, we cannot access it programmatically. So there's no API for us to grab it from, or there's also no JDBC connection or JDBC connection available that we can just grab the data and put it into our own data warehouse. The workaround is, or that I propose, is using a look. So we can expose the system activity data into a look. And then we can have a data action that is exporting data from the look into GCS. And then later on, we can have an external table that is just grabbing the CSV file from GCS as an external table. That's being said for Looker. So this is all the information we will know about the usage of Looker itself. On the billing side, on getting understanding what are the costs, we have 2 options. The first one is the billing data. This is also the example that I will use in my screen share later on. This is good for customers or for BigQuery customers that are using the so-called on-demand model. It's definitely the easiest to set up. So when you have a billing account, just configure the export into BigQuery, and then you're ready to go. The only problem is if you're a flat rate customer, or if you utilize BigQuery flat rate, then the consumption will always show $0 because in the billing data, the flat rate SKU is a different one than the analysis SKU, so you cannot bring them together, and consumption is then 0. If you are on flat rate, I would encourage you to look into the data access logs. They have more granularity. You will have to set up a log sync first and then export the information from the log sync or all the log messages into BigQuery. Especially for Germany-based customers, that could be an issue in terms of data protection and data security. I've seen customers that are not eager to do that because you could, in theory, trace back to specific employees and figure out how many queries does an employee run over the course of a month or over a year. And this is some kind of information that should not be accessible for everyone. So be prepared for some discussions, at least if you're based out of Europe. However, if you are a Google or if you're a DoiT customer already and using the BigQuery Lens feature, then DoiT is also managing this the setup for you. So if you have a relationship with DoiT already, that should be good to go because then everything is already being set up. But other than that, it's definitely like 2 hours maximum effort to set up log sync, export it into BigQuery, and so on. It's quite straightforward. 2 hours is even including reading documentation. We only need one for them, so we only need either the billing data or the data access logs. Both of them will actually work out fine. This is a very bad looking SQL, and I apologize for that, but it's just for making sure that we have a little bit of understanding what we are actually going to do. We pull in from this table here, we pull in the external files that are stored on GCS, which are about the Looker consumption. This includes fields like the dashboard name, the export name. It includes the email address of each user that is using Looker, but also includes the query type, if it's a cache query, if it's a scheduled dashboard, and so on. So there's a lot of data that we can actually later on use for slice and dice with the data. On the billing export, I'm just exporting some general meta information, and you will see here there's a random times 10 as fake cost. Since the example that I used only had flat rate costs associated, and I hadn't had time to actually pull in the PII relevant data, the audit logs for today, I just went ahead and just created a fake cost here. If you are on demand, this cost field is actually being exposed or filled automatically. So this is just a matter for the demo here, but I wanted to be very transparent that this is actually not real cost. And then what we're doing here is we are joining on a specific ID field. This ID field is the so-called history ID in Looker. I think it's now being renamed into history slug. It's now being a hash. However, it doesn't really matter. We can still join the information because this field is also being exported into the BigQuery billing export. As you can see here, this is what we are looking for. There's a label, which is called Looker context history ID. And then you can reuse this one for the join as well. That's it. This is all basically. I just want to switch quickly into a live demo. Let the demo gods be with me. So first of all, it's nothing really fancy, but what we're doing here is we are doing a small PDT. We're building or putting all the SQL code that I had on my slides, putting it in here, actually with a correct billing export or billing account here. And then we have some information. I'm just adding some comments here, but overall, since the join happens in the PDT, there is no real need for us to modify anything else except some group labels and also some casting. And then later on, this is basically what we can build. So we have on the left-hand side, we see the PDT. This is basically, when we go into SQL, this is basically my PDT that is being reused. But what we can do then is get the dashboard title or whatever dimension we want to use, and then use the billing data here. I use the cost for this example, and we can then see the cost per dashboard, but it would be also possible to get cost per users. Same method here. I'm just switching between email and the dashboard title. So we would actually have the dashboards per, or the cost per user that is running the dashboards or running the Explorer. We can even switch to cost per branches. So if you're a heavy user on branches as well, you could actually figuring out how expensive your dev workflow is. This would also be possible. But yeah, this is basically a one-step or one-time effort. This is the export to Looker lens. This is my look, which is using the system activity data, and I pulled in all the information that are actually possible. So title for the dashboards, the IDs, everything that we could need later on. As you can see, even caches, the runtime per query, and so on. So everything is in here. And this can be then later on used to export. So I have a schedule set up to export this automatically into GCS. And then there is a BigQuery table that is picking up those CSV files later on. Yeah, that was the first part, basically. So switch back to the slides. Yeah, we had the example. This is the main idea that I wanted to share. Keep in mind that there are some limits in terms of how many history rows you can export. It's only for the last 90 days. If you are on the elite activity, you can export more data, of course. There's also a concurrency limit. So try to have those jobs or those data export jobs into GCS. Try to run them at the mid or at night because there is a concurrency limit of 1 query at a time against the media database of Looker. So don't block that during business hours and do this probably off hours. Yeah, the next thing on my agenda was to actually speed up queries. So first part was about showing how expensive queries are. The next part is about speeding them up. And the tool, the feature that I want to talk about is BI Engine. BI Engine is an in-memory analysis engine, vectorized query engine in Looker. It's actually its own query engine, so it's not using the default query engine of BigQuery. It's running the work in a different worker environment and trying to put in all the data onto one worker, while the regular query engine tries to replicate the workers, having multiple workers spreading out the workload. But the BI engine tries to actually bring in all the data into one worker node with larger memory capacity to actually allocate more data into memory. If you are using BI engine, so there's a different pricing model assigned with BI engine, you have to commit to a certain capacity. If you're not, or if you're using BI engine, then the query is usually not being run on demand or flat rate pricing. It tries to run the query first on BI engine, and if this is not succeeding, or if it needs more data because the in-memory part is not enough, then its fallback is the on-demand / flat rate pricing model. The good thing is BI Engine is also available for ODBC, JDBC connections. So whatever BI tool you use on top, it's not only Looker Studio, but also, for example, connected sheets or everything else that has a JDBC connection, a BI tool is supported here as well. The recommendation is to only use this for very high-level analytical queries. So if you, for example, have, if you want to calculate measures like max, min, averages, and so on, but it's not very good for transformative queries. So it's not actually being well, it does not support them, first of all, and also there are some restrictions on the table size and so on. So it's actually made for BI workloads that are just aggregating, probably joining a dimension table with a fact table, but it's not being made for large transformative workloads. External tables is not supported. Some UDFs or UDFs in general are not supported. So it's definitely made for calculate something, have a dimension table, have a fact table, and join them together. And this is where then the BI engine comes into play. The pricing is a little bit weird. If you're used to on-demand or flat rate pricing, you're paying per gigabyte per hour. So you have to commit for a certain capacity, BI engine capacity, which is being built at an hourly level. And you can, the good thing is you can actually turn it off during off business hours. So for example, what we do internally with our dashboards, we turn the capacity or we scale the capacity based on the business needs, so that we don't pay for an unused capacity. And this is, I think, quite easy to manage using, for example, workflows or any other scheduling tool, because the BI engine has an API to manage the capacity. It's a little bit, worrying sometimes. So I just made a capacity reservation for 150 gigabytes, and it says I should pay $4,500 for it. Usually I recommend customers that are just getting started to look into capacity around like 20 gigabytes, most 50 gigabytes to get started, because there's no real prediction that we can make upfront. But you will get some insights in cloud monitoring. So whenever you have a committed BI engine, you will see how much of it is actually being used. So this is a good instrument to also figure out if you should go with a lower reservation or higher reservation. But there's a little bit play around, figure out what is a good instrumentation, what is a good sizing. Every job that is being executed, even the ones from the UI, get a little annotation here. So in this example, it says BI engine is at full capacity, or the full query is being accelerated on BI engine. Actually, it's being speed up, and it's not using, as you can see here, built by any on-demand pricing model. However, if the query cannot be run on BI engine because of one of the restrictions I mentioned before, you would actually see the error code via it fall back to another query engine. All the information is also available via the information schema. I built a quick or a short dashboard, which actually shows all the BI engine error codes, shows the status code, why they failed, the number of jobs, and so on. So there's some possibility to visualize the meta information of BI engine queries as well, using the information schema, and then put it onto a dashboard. Cool. The last topic, so basically the second topic was about speeding up. All the queries that are running via BI engine are usually by a factor of 5 to 50 faster than a query that has been run on demand, if it's being a supported query, ETL BI tool, sorry, BI related query, and not an ETL query. The last agenda item for today is slots. Usually a lot of tickets, a lot of questions that I get. When should I use slots? The pricing model is not clear. How many slots should I buy? Is it enough to buy 100 slots? Does it really make sense to go into a commitment? Because the on-demand pricing model is basically, if you don't use it, you don't pay for it. But for slots, you have to commit for at least a minimum of a month. Or maybe you can also, or you want to commit for a year, which makes things easier or cheaper at least. But sometimes this adds a little bit of confusion or complexity. So first primer, why do we actually have flat rate, or what is flat rate? If you are on the on-demand pricing model, you have 2,000 slots per project. And there is a pay-as-you-go. I put in here I think it's right now the EU pricing, $5 per terabyte. Some regions are now at 6.5 or $7 terabyte, but this is basically pay-as-you-go model for the amount of data you scan. The opposite is the flat rate model. You buy a given amount of slots, and then you're not paying for the bytes that are being processed anymore. Basically, you're just throwing a query into the allocated slots and try to run it at the capacity. You can either sign up for 100 slots for $2,000 a month, or there's a new method called flex slots, where you can sign up for 100 slots for $4 per hour. This looks a little bit complex, not very easy. So let me just do a quick example here. The easiest example is we just offload all our BI engine or all our BI related queries to a dedicated reservation. So we don't have the spikes anymore in fluctuating costs, depending on how many queries are being written via the BI tool. If we put everything into a committed 300 slots during working hours, or if we put them onto a monthly commit here, this would actually get us into a 6,000 ballpark. So this also answers the question, is this something you should look into right away? If your BigQuery spend is much lower than 6,000, I would definitely not recommend to look into that at all. If you are spending right now on demand roughly 6 to 10K already, I think then this is a good recommendation to look into buying slots, because you can also buy the slots at org level and then redistribute them to other projects if you don't need the slots. But keep in mind, slots are being bought in this case on a monthly level. One thing, and this is very, very special in terms of how your business operates. One example from one of our customers, they have an ETL job that is just being run once a month, and they're just calculating all the invoice sums basically in BigQuery, because this is a predictable workload, but a very heavy workload. They look for optimizing the cost around this, and the solution we provided or we worked on with them was actually provision flex slots via an API. So flex slots also is, or all the reservations can be triggered and can be brought via an API as well. So you should, or in this case, the customer provision the flex slots before the workload started, then assigned the workload or started the workload, and after the workload has been finished, they deprovision the flex slots. In the end, this resulted in much lower cost because they had just the fixed amount of slots during this time, and they just threw in the workload. And they haven't had to think about the on-demand pricing model anymore. But on the same time, they did not commit it to a monthly reservation because it was just for a once or twice event during the month. This can be nicely scheduled via Cloud Workflows or Airflow Composer. So whenever you have those time-critical workloads or those workloads that are just running at specific times, you can just introduce new tasks before and afterwards to bring in the slots. This is kind of not really an autoscaler, but at least it provisions you slots that are, or that can be deprovisioned afterwards after the workload has been finished. This is a great tactic to actually reduce or bring in or move from fluctuating costs towards more stable costs, which your finance department will also like probably. Perfect. And that's it for this session. We covered dashboard costs, how to visualize them by bringing in the billing data, drawing them together with the system activity data. I explained a little bit about BI engine. There is, since I think last week, a very good Google blog article that explains how BI engine works under the hood. So if you're interested in a little bit more technical understand or technical mechanisms, I definitely recommend that one. And the last one was about slots. So if you're using or if you're having an on-demand pricing model right now, I would definitely also encourage to look into slots if you're meeting a certain threshold of BigQuery consumption. Perfect. That's it from my side. Dylan, do you want to continue?
Yeah, absolutely. Philipp, thank you very much for that. That's been super, super interesting. We've got a bunch of questions coming in the Slack channel, which I'm going to read out in a second. But if anyone missed it earlier or needs a reminder, we're going to pull all the Q&A questions from the Slack channel that we have. I've just dropped the link again. If you need to share up, you can find it in webinar BigQuery cost optimization channel. So the first one, Philipp, which I will ask you is from Anthony Billett, who is at GCP, says the Looker GCP team has created some cloud cost optimization marketplace blocks, either for cross-cloud analysis as well as like GCP, Azure, AWS specific. Do you have experience? And that's both there's an open source block and something you can install via the marketplace. Do you have experience working with these? And if so, do you recommend them? Or is it better to take this approach and build something custom like you've shown us today?
I think they are definitely a good start. So especially since the insights that you can generate from especially the BigQuery one are very, very good. So figuring out not only for Looker related queries, but also for the queries that are running in the organization. I use them quite often to train people as well. So figuring out what are bad queries, which are the bad actors on BigQuery, to figure out how those teams can be trained to write better queries. So this is definitely something where those blocks come in handy. Yeah, this is pretty useful, especially if you use a Looker customer. Then it's just a one-click deployment if you provide the service accounts.
Yeah, I think what I'd add, I agree. I think the blocks themselves are great. I think there is something that you unlock when you can aggregate things up to like a unit in Looker, like a dashboard or a look or a user, things like that, which I don't think, as far as I'm aware, those marketplace the marketplace stuff does today. But I agree with Philipp that as a starting place, particularly given it is literally just one click, it's a great place to start. Got one from Rafal here who says, as a rule of thumb, is there much difference in terms of both cost and performance between putting complex logics into PDTs versus scheduled BigQuery tables?
Was it about cost or performance? What was the
both? I think was the question.
the criteria. I mean, scheduled queries is a vehicle to orchestrate something, but long term, I would definitely look into something more advanced, especially PDTs in conjunction with the data group feature. It's much more than a cron job. It's much more than running a table or orchestrating a table. You have the option to use the data groups in conjunction with the dashboards, in conjunction with the table caches and so on. So I would definitely encourage to rather look into the PDTs because everything that the PDTs are building is then also accessible from the BigQuery UI again for other teams, right? So it's not a lock-in effect. You just use the functionality of Looker to make it available into BigQuery. So if the choice is between scheduled queries and PDTs, I would always go for PDTs.
Next one, you focused on kind of slots, BI engine, stuff like that today. Any thoughts on clustering and partitioning data to optimize cost and speed? And is there a relative importance in your mind of slots versus BI engine versus the kind of more traditional data warehouse clustering, partitioning, stuff like that?
Clustering, partitioning comes first. So whenever you design your data model, clustering, partitioning should be the first thought that you should have. BI engine, slot allocation, and so on are second class citizens. So this is something that you should do after you build your good data model in here. And also BI engine, just expect that you have partitioning in place, because keep in mind, if you just want to load data into memory and you just want to load the data that is being used, then partitioning is actually mandatory to work great for BI Engine.
Yeah, just to add to that, if you're watching this, you use BigQuery and you're not familiar with clustering and partitioning, I'd definitely go have a look at that. It can make such a radical difference, particularly if it's tuned well to the cost on running BigQuery. It may well be something that we'll cover in a future webinar as well. But if you're on BigQuery and you're maybe newer to it, you haven't had a look at that, definitely make sure you do so. Got one from our team, from Josh. He says, when it comes to cost reduction, what should you focus on at kind of small, medium, and large enterprise scale data teams and companies? Is there a difference kind of at low budget, medium budget, large budget as to what moves the needle the most?
Very difficult question. I think it comes back to educating the teams. So especially if you get started and if you learn some bad practices, then they will evolve even into larger enterprises or larger customers as well. So make sure that you understand the database that you're using before actually putting a BI tool on top. But this applies to all sizes of business. I think for larger enterprises, it usually it's a matter of transparency. So usually people are not aware of how expensive a dashboard is. So because there's so much money in BigQuery, we spend so much money on BigQuery, it doesn't really matter if we save $5 now for this specific query. And then I think this is a great start to actually look into how much each branch costs you, how much do you pay for development and so on. So especially for larger enterprises, I think the savings are definitely much bigger.
Let's do two more, if that's all right with you. So I think this refers to the first bit that you talked about where you were joining the Looker data with the underlying BigQuery billing data. The question is, can we drill down to a model level? Can you kind of take that query that you ran that joined these things together and drill down to a model level? And if so, how do you achieve that?
I was able to actually get onto Explore level. Model level, I haven't seen it yet. The problem is model is not being exposed in system activity as far as I know. I have to look into, but Explore and Dashboard is definitely possible. I don't know if model is actually being exposed on the system activity. This is something I need to double check.
In theory, I guess, given that there's only so many Explore to model mappings, you could possibly maintain that yourself and join that in as well if you needed to. Yeah.
You need to just figure out the history ID together with the model, and then this would be joined.
Where do you see people most go wrong when trying to reduce BI spend? Do you see people spend time in areas that end up not being kind of fruitful, end up kind of the effort they put in doesn't end up kind of reaping the rewards because of how they're focusing on it?
Don't micromanagement. So if you see someone that is always writing bad queries, but it's just like a very small query, don't try to convince them too much. I think micromanagement is definitely the wrong place or the wrong method here. Keep in mind that your working costs or that your hours that you put into optimizing for queries is also coming with a price tag, right? So if it's more expensive to actually work on the query or to optimize the query than just run the query, I think this is something you should always keep in mind, that you also have a price tag.
That makes sense. I think that's all the questions we have. So I'm gonna stop there. Philipp, thank you very much for answering all of those. And I'm just going to share my screen one last time before we finish up. And it's really just to call out to everyone the webinars that we have coming up. So if you enjoyed today, as I said, you may have joined us previously, but if you haven't, we do these every other week. And so we've got these next three coming up. Optimizing Looker performance on snowflakes in 2 weeks, creating custom map visualizations in Looker is 2 weeks after that, and multi-instance scaling for use cases at Scopely. It's kind of a Looker user for the first time coming onto the webinar and talking about their deployment and how it evolved over time. Those are over the next 6 weeks. So if you head to spectacles.dev/webinars, you can sign up for those. And just a call to action again for everyone. if you have something that you think, hey, we've done something really cool on Looker and we'd like to shout about it, or you have an area of Looker that feels kind of moderately complex that you think you'd like someone like us or one of our partner experts to talk about, please just get in touch. We'd love to chat with you about all of that. And then finally, I haven't talked a ton about who we are today, but if improving your Looker instance, getting better testing on your Looker instance, improving developer efficiency around your Looker instance is something that matters a lot to you, come have a chat with us. We have our 14-day free trials. We're always really interested in talking to people who are using Looker and seeing where we can help and where the tool can help. And so there's no, you kind of have to make no commitment there, but if you do want to come chat with us, please do so. So before I finish, just Philip, another big thank you to you. This has been really, really interesting. We work regularly with the team at DoiT and recommend them a lot if you're, particularly if you're a GCP shop and you want some experts to work with. The team over there is fantastic, and I'm sure we'll have them on again for one of our future webinars. So that's everything for me today, and thank you to all of you for attending. We've had a really great turnout today. It's been fantastic, and so just looking forward to the next one. Awesome. Thank you very much, everyone.